All right, number 5, we want to use symmetry to evaluate the following integral. Secant comes from 1 over cosine. Cosine is symmetric about the y-axis, so this is going to be an even function. I'm going to put an e up here. Negative pi over 3 to pi over 3, 7. I'm going to pull that constant out. Secant squared x. All right, since this is even, I can just double this. So 2 times 7, that'll give me 14. I'll just write double the integral from 0 to pi over 3 secant squared x dx. All right, when I use the trig functions, I like to look at the integral sheet to see the integration or the integral for these trig functions. So I'm going to go to our cheat sheets. I want to go to integration. And then it gives us some of our properties and some common integrals. And here we go right here. Secant squared u, or x, it doesn't matter what variable they use, is equal to tan u plus c. Remember, we hadn't been writing the plus c. It cancels out whenever we're plugging in our limit. So tan u is going to be our integral. So this is 14 times tan of x evaluated from 0 to pi over 3. And then 14 tan of my upper limit pi over 3 minus tangent of 0. Now, using our unit circle, tangent is sine over cosine, so I'm going to write that as pi over 3 and cosine. Pi over 3 on our unit circle we can't even see that circle. Pi over 6, pi over 3. So we go over, this order pair is 1/2 square root of 3 over 2. So x is 1/2 square root of 3 over 2. 2's will divide out, so this part we just get square root of 3. And then tan of 0 right here is 1, 0. So the x value is sine of 0 and cosine of 0. This is 0 over 1, which is 0. So minus 0. We are going to get 14 times square root of 3 as our answer.